Now let's see how we would use this in an actual problem. So let's ask, does sum from n equals 1 to infinity of negative 1 to the n over n squared converge or diverge? So first of all, what does this series look like? What it looks like is, this is going to look like negative 1 over 1 plus 1 positive 1 over 4 minus 1 over 9 plus 1 over 16, etc. We'll just keep going. So that's what that series looks like. Now you might say, well, isn't this just a p-series? But actually, it's not. Because p-series had to be of the form constant over n to the p, and negative 1 is not a constant. The other thing also is none of the tests that we've learned so far, such as with the exception of the divergence test, which doesn't apply here, the two comparison tests that we learned both require that the series have only positive terms. So you can't actually use those tests directly on this kind of series. What we can do is we can answer the question by asking a related question, which is we can reframe this as, does the sum from n equals 1 to infinity of absolute negative 1 to the n over n squared converge? Because if it does, then by the absolute convergence test, so would the given series. So let's see if it does. What we can do is we can observe that sum equals n equals 1, sum from n equals 1 to infinity of negative 1 to the n over n squared is just equal to the sum from n equals 1 to infinity of 1 over n squared, right? Because if I take all these terms and make the negative ones positive, I get 1 over 1 plus 1 over 4 plus 1 over 9 plus 1 over 16, etc., which is just equal to that series. So now we do know, of course, that the sum from n equals 1 to infinity of 1 over n squared converges because it's a p-series with p equal to 2, which is greater than 1. Therefore, by the absolute convergence test, the sum from n equals 1 to infinity of negative 1 to the n over n squared also converges. And we're done with the proof. So that's how you would prove that statement. It doesn't seem like we've done very much, but we did learn something in this section. We learned that that we can determine that this series converges by proving that this series converges, and that's a significant point.